In this video, we're going to review one approach for creating a Maestro model of the deck house for this ship. The first thing we'll need to do is to decide how we want to break up the ship into Maestro modules. Typically, we use the watertight bulkheads as a starting point for the module boundaries. So the first thing we'll do is to create a transverse cutting plane that covers the entire extent of the ship. We'll then move this cutting plane forward to the location of one of the watertight bulkheads. To make that a little easier, we'll hide all the other layers, and then we'll use the setPoint command to change the X value of that plane to be on one of the watertight bulkheads. Now these have actually already been created, so we can delete that surface and simply turn on the module boundaries layer, and you can see we have our cutting surfaces at each of the watertight bulkheads. If we turn on all of the layers we just hid, we can see that these cutting planes actually are at a pretty good location for breaking up the deck house. The procedure that we're going to use to build the deck house will basically be as follows. First, we'll want to extract all the curves from the geometry to create Maestro endpoints. This will basically consist of all of the stiffener traces on the hull and the superstructure, as well as any feature curves on the hull and superstructure, such as the deck edge, the chines, any longitudinal knuckles in the house, the edges of the top of the deck house, and the curves defining the cutouts for the windows and doors, and say the aft end of this fascia plate, so that we could create meshes to model some of these features. Once we have all the geometry curves for defining the endpoints, we'll break them up and place them on individual layers so that each module will be sort of separated from all the others. I've created a layer called endpoints, and under endpoints we have two layers, one for the house and one for the hull. Under the hull we have 7 additional sublayers, one for each module moving forward. If we turn on the module boundaries, we can see we'll have module 1 at the transom and moving forward all the way to module 7, which is the bow. Under the house we have 3 modules available for modules 4, 5, and 6. Once we have all of our endpoint curves placed on each one of these module layers, we'll then clean up the endpoint lines so that we can use a Rhino script which will export the Maestro endpoints and strakes. This will define on the superstructure, it'll define all the longitudinal bulkheads and deck surfaces. While there aren't any stiffeners located on these 2 longitudinal internal bulkheads, we'll make copies of the longitudinal stiffeners on the side and copy them inboard so that we can create strakes to model these longitudinal bulkheads as well. Once we read the strakes into Maestro, we'll then break up those modules into the desired number of sections. We'll probably break it up into 2 sections per frame bay. Once we have all of those node locations in Maestro, we can then export all of the nodes back into Rhino so that we can use them as reference points to create any meshes for internal bulkheads, such as these transverse bulkheads, as well as for any of the cutouts around the windows and doors or these fascia plates, as I mentioned earlier. By using those as reference points, we can be sure that any new meshes we create in Rhino will join properly when we import them back into the Maestro model. So now let's start by making copies of all of the longitudinal and deck stiffeners. We'll select those 2 layers and then select all the objects. To make our copies, we'll simply cut and paste, and while they're still highlighted, we'll go onto the Properties tab and change their layer to the Endpoints layer. Now if we turn off the longitudinal stiffeners and the deck stiffeners, we can see they're still shown in the model because they're now on the Endpoints layer. If we turn off all the other layers, we can see our copies are a mix of red and black lines. Just to keep things a little organized, what we'll do is grab all of these endpoint lines that were based off of the stiffeners, and we'll make all of those black. For any of the feature lines that we extract from the hull and superstructure, when we extract them, we'll make them red just so we can differentiate later which ones were created from strakes and which ones were created from hull feature lines. To select our hull feature curves, we'll start by turning off some of these layers to make selecting the geometry a little easier. And I believe the curves layer is empty, so we'll make the curves layer current so that we're able to turn off the endpoints layer so we don't have to look at the copies of the stiffeners that we just made. To extract our feature curves, we'll use either the duplicate edge or duplicate border commands. For duplicate edge, we can simply go in and grab an edge of a surface. In some cases, there may be quite a few edges, such as like along the stem here. It's broken up into very small pieces. That'd be somewhat difficult to extract there. The other option that we have is to use the duplicate border, which, like on the top of the house, if we duplicate the entire border, we get the curve surrounding the entire surface. So that's been extracted to the curves layer. We can duplicate edges, such as the edges of that fascia, and we'll run around the hull and extract all of these curves. Once they've been pulled out, we'll select them, change them to red, and move them to the endpoints layer. Skipping forward, we've now extracted all of the feature curves from the hull and superstructure. You'll see them displayed in red. Most of them will be used for creating the endpoints and strakes for the structure, but we've also included a few additional curves, such as these outlines of the windows and doors, that'll be used as trimming curves for modifying the longitudinal structure later. You'll also see a cyan curve in here. This was done as an intersection between the surfaces and a center plane. Since the hull was symmetric, we're able to just model half of the hull, and when we import it into Maestro, we can then mirror it to the other side. Initially, looking at the superstructure, it appeared to be asymmetric, so I thought we would need to model the whole thing. But if we take a closer look, since all of the longitudinal structure defined by these endpoints appears to be symmetric, if we take a closer look, we can see that the asymmetries appear to be limited to the transverse bulkheads. This should allow us to also model just half of the superstructure with the endpoints and strakes. And once we create our reference nodes in Maestro and import them back into Rhino, when we build our transverse bulkheads, we'll simply build the full width of the bulkhead with all of the asymmetries included. Our next step will be to join and split up the curves and move them to their appropriate module layers. So the first thing we'll do is select all of our curves and join them. Then we'll split them up using our module boundaries. And now we can grab them in groups and move them to their appropriate layer. Since the hull and house layers were currently turned off, as we move them, each one will disappear from the model. Skipping forward, you can see we've deleted all the curves defining the port side of the house. We've also taken all the remaining curves and moved them onto the appropriate module layers. To start, we'll turn off all the hull layers and just look at the house. You can see we've kept the curves defining the deck and made copies of them and put them in the house modules. The only endpoint that we'll actually use from these deck curves in the house is the one that will be shared by strakes in the house and the hull, and it's this curve at the decked edge. The remaining curves on the interior of the deck are there for reference, so that when we later build our transverse bulkhead, we can be sure that the nodes at the bottom of the bulkhead will tie in with the structure for the hull. Next, let's isolate on Module 4 and begin preparing the endpoints for the export script. The first thing we'll do is turn on our module boundaries, and we can see we have a little overhang here which won't be used for the endpoint script. That'll be built as a mesh that's added on to the strake modules. So for the time being, we'll hide those. Currently, the endpoint script requires that all the lines that are selected to be endpoints be defined by 2 points. If we turn on the control points for all of these curves, we can see that while on the top of the superstructure the curves are actually single line segments, a lot of the other curves have a lot of interior control points. The easiest way to convert these curves to single line segments is just to simply delete all of the interior control points, leaving only the ends. Skipping forward again, you can see we've now deleted all the interior control points from all of our endpoint curves. The one exception is this red curve defining the edge of the top of the deck house. If we look at it in plan view, we can see that that curve is parallel to the center line over about 90% of its length and only begins curving in at the aft end. If we were to delete all the interior control points, that line would taper in over the length of the module. In order to keep most of it straight and parallel to the center line, what we'll do is create an additional line based on the straight line portion of this curve, and we'll use that for our endpoint when we export the strakes. We'll retain this red curve as a trimming curve for use later, but for the time being we'll hide it so we don't get the two confused. The next thing we'll need to do is to prepare our endpoints for export using the script. We'll need to extend these curves to the end of the module boundaries, which are these clipping planes. To do that, we'll simply extend our curves and select these two boundaries, and then we can just begin clicking on all of the endpoint curves that don't yet make it to the module boundaries. Once that's done, our endpoints are now ready to export, but we'll still need to create a polyline so that the script will know how to attach them into strakes when they're imported into Maestro. To create our polylines, we'll need to extract points defining the ends of the curves. The easy way to do that would simply be to highlight the curves, use the extract points command, and then we'll unselect the points that we want to keep and delete the rest. Since we won't be using the interior deck curves for generating strakes, we won't need those points, and we can delete them as well. To create the polylines defining how the strakes will be connected, we can simply select groups of points and use polyline through points. To get this vertical bulkhead, we'll select that group of points and make another polyline. There is one additional longitudinal bulkhead that we'll want to create, and that was for this surface in the wheelhouse. In order to do that, we'll simply grab all of the curves on the outside of the house, cut and paste to make a copy, and then use the set point command to reset their Y value to this location. Since we already have endpoints that are very close to that longitudinal or that transverse location, I think what we'll do is we'll move that bulkhead inboard so that it lines up with these existing strakes. That way we won't have to have a very small quad in the deck at this point. And we can do that by simply selecting that point. And now we can come in and create the polyline that'll define those strakes. We're now ready to run the endpoint script. In order to make sure that the strake normals in our module will be consistent, one thing we may want to check is to look at the direction of these polylines that define how the strakes are connected. From trial and error, we know that going counterclockwise in this model will put the frames on the interior of the defined strakes. So we'll reverse the directions of these so that our frames will end up on the inside of the model. This one will actually, since that's a passageway, we'll try and make the frames on the inside of this compartment. Now we can run the export script. First thing we'll do is select all of our endpoint curves. As we mentioned earlier, we're not going to be using the interior deck curves. And then we simply select our polylines defining how those get connected and save them to a file. We'll save these in House Module 4. The next thing we'll do is come into Maestro and read the file that we just created. We'll do that using the import PLY polygon file format importer, which will read these text files. And when it goes to import, one thing we'll need to do is, by default, Maestro wants to use meters, and our Rhino model was using millimeters. So we'll change our units accordingly, and we'll also transform the nodal coordinates. Maestro uses by default a positive Y up, and Rhino was using positive Z up. When we import it, we see we have one mesh, or one module rather, with all of the strakes we had just defined. The module name is the same as the file name, and we can come in and change our module properties. This is where we'll change the number of sections per bay. By default, we only have one section that's 5,220 millimeters long. To make it 2 sections per frame bay, we'll need to change that spacing to 435 millimeters. So we'll remove the existing section in there, and we'll add 12 435 millimeter sections instead. The other adjustment we'll need to make is to tell it that there will be 2 sections per frame bay rather than 1. Now what we'll need to do is take all of these node locations and get them back into Rhino. The easiest way to do this is to go into Results, List, and Nodes, and this will list all the nodes currently shown on the screen. We can grab these XYZ values, simply highlight all the XYZs, and copy them to the clipboard. Then we'll use any editor that can do substitutions and substitute all of the tabs in the copied data with commas. And then once they're comma-separated pairs, we can simply paste them into Rhino. And now in Notepad++, we can paste in all of the Maestro data that we just copied. You can see it's currently tab delimited data, but we can use the replace command to change any of the tabs to commas. The \T using regular expressions will substitute all of our tabs with commas. Now we can use Control-A to highlight everything and copy these comma-separated values to the clipboard. Moving back into Rhino, we can now insert all of our Maestro nodes into our model. But first, let's delete all the points we previously created so we don't wind up with duplicates. We'll simply select the points and remove them, and then use the points command to insert the Maestro nodes. Where exactly they will come in will depend on which view is active when we issue the points command. Using the front window, we'll put the points in the correct orientation. If when they're imported you see that they show up in an unexpected location, you can simply hit Ctrl-Z to undo the operation, change the window, and try again. Once the points command active, we simply paste that long list of comma-separated points onto the command line, and when they're done, complete the command with a blank carriage return. And the points will show up in the model. You'll see they correspond nicely to our endpoints, and we're ready to start building our meshes. First thing we'll do is to unhide all of those trimming curves and the overhang that we hid earlier, and we'll hide all of our endpoints to make it a little easier to select our nodes when we're building the meshes. And we'll hide those polylines that were used for defining the strakes. First thing we can start with is building this overhang. If we were to build these as single quads, they would be a good bit longer than the existing mesh in the Maestro model. So we'll cut this in half. Actually, we'll use this endpoint and simply cut a section through the remaining curves to generate some additional points to use. We'll also need points defining the end of the overhang. So first, let's grab all of these curves and we will extract points and unselect the ones we want to keep and delete the remaining ones, since we already had point locations there. We'll select all of the interior curves there and use the section command and cut a section through them. Now we can use all of these points to generate our mesh. An easy way to do that is to create several polylines and loft a surface between them, and then you can use the mesh from NURBS control polygon to convert that surface to a mesh. So we'll start by grabbing all of these points, creating a polyline through points. Do it again, and a third time. We'll select those three curves and loft a surface between them using the straight sections. And now we can select that surface, which is actually a poly surface. And if we use NURBS from Control Polygon, we'll see that it won't allow you to use a poly surface. They need to be individual surfaces. So we'll escape, explode that poly surface into 11 individual surfaces, and then convert it. Now we'll select the surfaces and delete them, and we're left with 11 meshes. We'll need one additional mesh at the end here. So in Mesh Tools, we can simply create a single mesh face. And rather than the node in Maestro for that strake, we'll use the end of the trimming curve. And we'll create a substitute quad for that last quad on the strake when we move this back into Maestro. When this is pasted into Maestro, we'll delete the existing straight quad there, and this quad will take its place. We can select all of these meshes and then join them, and now we have a single mesh representing our overhang. We can start creating a mesh for this fascia plate. To make it a little easier to see what we're working with, we'll use a clipping plane and flip the direction of it so that we're just looking at the outer bulkhead there. And we'll need to create a mesh in this region, which we can use that same procedure we just did. Where we create a polyline through points, and a second one. Oops, I had an extra point there. And a third. We'll loft a surface between those three polylines. Again, we wound up with a poly surface, so we'll have to explode it, convert the surfaces to a mesh, delete our surfaces, and we're left with a mesh. We'll join these together, and now we can start trimming this to fit that trimming curve for our fascia aft. In the mesh tools, we can use the delete mesh face to get rid of some of these that we won't need. We can use the split mesh edge to divide that one and delete the remaining faces we won't need. We'll turn on the mesh points so we can move them around, and we'll grab that mesh point and slide it aft until it intersects with our trimming curve. We can do the same thing with these remaining points, sliding them forward. Slide this one up, and in this corner we'll need to create an additional point in here. We can split this mesh edge and put it there for the time being, and then we can use the merge two mesh faces to convert that to a quad and that to a quad. We can delete that remaining triangle. We have a reasonable approximation for our fascia. We can refine that later if we want. Actually, we can divide that again. I accidentally cut that twice. And merge these faces and move that around slightly. That looks a little better. Using these methods, we can continue forward creating a small trimmed plate around the windows if we want to tie it into the existing mesh, as well as any of the interior bulkheads for the aft face of the wheelhouse, as well as these transverse bulkheads on the back of the deck house. Jumping forward, we've now created all of our meshes in Rhino for Module 4. You can see we have the trim plates around the window. We've created the tie-in for the forward end of the passageway where it'll tie into the Maestro strakes, as well as the asymmetric bulkheads. If we turn on our surfaces, we can see how well they agree with the originals. And these are done by simply creating a mesh on one side, mirroring it, and then making the adjustments for the asymmetry. We have two options for exporting. We can either export in two separate modules, one that would be all the asymmetric bulkheads, and another that would be all the symmetric meshes. And then the symmetric portions could be mirrored in Maestro, or we can simply mirror them now and export everything as one large asymmetric group of meshes. So we'll go ahead and select all of these meshes now and mirror them so we can export them in just a single file. One last thing to review is how we created these bulkheads. Similar to how the overhang was created, we lofted a surface and converted it using the mesh from the NURBS control polygon. But unlike the original overhang mesh, we had separate lines when we created the lofted surface. Here, we would simply create the polyline for the top of the surface, and the polyline for the bottom of the surface. Loft a surface between them using the straight sections. And then we can use the Edit Control Points Insert Knot to create the interior control points at each one of these adjacent vertices that we'll need to tie into. And now our surface has the interior control points. And if we create our polygon mesh from the control polygon, we can see we have all the interior vertices we need. So we'll undo that creation to get back to the original mesh. And now we can export our meshes for the Maestro module. When we export, we'll export as a PLY file. And we'll just use the ASCII format. Moving back into Maestro, we can now import the meshes that we just created in Rhino and begin cleaning up our model. We'll once again transform nodal coordinates, and our units are still in millimeters, so we can just import. So at this point, we'll need to delete any of the straight quads that will be replaced by the meshes we just imported. This is very easy with the deletions dialog. We'll want to make sure that the full strake is unchecked so that we only get the individual strake quads. Now we've got a few extra quads in there that we didn't want, so we'll grab those and return them to the model, and then we can delete. Next, we'll have to delete this plating behind that piece of fascia that we created. Again, if we accidentally get a few quads, we can easily return them to the model and then delete. We'll need to get rid of that corner piece that we replaced. We'll remove those quads. And finally, this longitudinal bulkhead forward of the passageway. And I believe aft, we'll need to remove this. At this point, we have most of our basic geometry done. We would then start on assigning properties to all of the plating, as well as adding the stiffeners. In the areas of the strakes, there's one additional spot we'd need to clean up, where it ties in at the base. So for the longitudinal stiffening, we would create beams and turn on the girders on these strakes. We could add beams to the bulkheads where required, and also we can turn on the frames on these strakes to generate the framing cross structure. Once we have all the properties assigned, we could simply come in, set the symmetry flag on the job information dialog, and then mirror the module containing all the strakes. Once it's mirrored, we could merge these together and we would have most of our house for that module built.